In example 3, we're going to be finding the domain of the following functions. We have two of them here, f of x and h of x. And one thing I'm noticing right away is that I don't have any radical signs, but what I do have is a fraction, and I have some variables, or a variable in the denominator. So this one, we want to find the value that's going to make this 0, and I'm going to put a not equal to sign here, because we don't want the bottom to be 0. We need to exclude whatever value we find. So we're going to add 4. So x cannot be 4. So we're going to use just interval notation for this, not set builder. And if you did a graph, here's what the graph would look like. Any other number, with the exception of 4, would work. So in interval notation, we're going to have two pieces. We're going to have the negative infinity, up to but not including 4, and then not including 4 up to infinity. This is your solution. This is the domain of this function. 4 is not in the domain. 4 minus 4 is 0. The bottom would be 0. We don't want to list that value in the domain. Same thing would appear to be the case here. So we don't want that bottom to be 0. Try to factor this one. Negative 4, we want negative 4 and positive 1. 1x minus 8x is negative 7x. So we've got 2x plus 1 not equal to 0, or x minus 4 is not equal to 0. If we solve this, we'll have x, and we'll divide by 2 here, not equal to negative 1/2, or x is not equal to 4 if we just add 4. Here's our number line. These values don't work. Everything else in the middle does. Left, middle, and right, I should say. So to write our interval notation, we're going to go negative infinity to negative 1/2, not including negative 1/2. Next stop is 4, and then 4 to infinity.